It's that time of the day that we're going to be taking more derivatives, guys. Aren't we super ecstatic? So, if we have f of x equals e to the x, we have f of x equals a to the x. We have to find, well, methods or learn the methods of how to take derivatives of these functions. You know, polynomials are fun. You do the power rule, the sum rule, difference rule, right? So what happens is that if you do the definition of derivative, we know that the derivative at 0 for e to the x equals 1, just from previous notes. So if I do the definition of derivative for e to the x at f prime of 0 equals a limit as h approaches 0 for f of 0 plus h minus f of 0 all over h, which is limit as h approaches 0 of e to the h minus 1 all over h. But thing is, if I put in 0, well, I can't actually. Oh, this is a fact. So it is more of a memorabilia thing that this actually equals 1. Something to memorize. Because yeah, I agree with you. You're like, hey, I can't put 0 in the bottom. You're 100% right. Like I would not have intuitively knew that. But this is just something you have to memorize, that e to the h minus 1 over h is equal to 1. So, well, I guess what happens is if we do the definition of derivative to prove yet again another derivative, it's going to be fun. It's that time of the day, proving the derivative of e dx. So if I go f prime of x equals a limit as h approaches 0 of f of x plus h minus f of x all over h. This is kind of a useless line because we've done already, but okay. H. Yes, I am copying this right off because of time purposes. What you can do is, because they're being added secretly, they're being multiplied, right? They're multiplied if you're adding the exponents. So what we can do is factor out an e to the x essentially, and we go ahead e to the h minus 1 all over h. We just said that this little chunk right here, yeah, like that, looks like an enzyme. That little chunk right there equals 1, so it's e to the x times 1. So the derivative, aha, of e to the x is e to the x. Bam! You know it. You know it. So we're going to use that from now on, team. The derivative of e to the x equals e to the x. That's an x. Oh, shoot. That's an x right there. That's what the derivative is. Of e to the x is e to the x. So that's what that is. So let's look at some examples. Like, what's the point if we can't apply it? So what's the point if we can't apply it? So if I have f of x, getting ahead of myself here, equals 2 e to the x, same thing, you can apply the constant rule where I take out the constant, so f prime of x simply just equals 2 e to the x again. Wow, that was not hard. But if I have f of x equals x times e to the x, now I have two functions. That is not a constant. So I'll do f prime of x as a derivative of the first one, which is 1 times e to the x plus e to the x times x. So I get e to the x, 1 plus x. Okay. If I have, f of x equals e to the that, that's a little ugly. It's got exponent as a function. I'll do chain rule. I'll just do e to the 1/2 x, well, e to the power of x to the 1/2 times the derivative of that, which is just going to be 1/2 root So that, essentially, if you simplify that, it's that beast right there. That's what that is. Let's do these like flipping clockwork, dude. Chain rule. Chain rule. Chain rule, man. Woo-hoo. Chain rule. Do every day. You know us. You know how we like to do this. E to the 3x squared plus 5. E to the 3x squared plus 5 times 6x. Done. What if we have f of x equals a to the x, though? What happens now? Well, a equals e to the ln a, because you cancel out the e and the ln, get back a, the log property. So that would mean that a to the x equals e x ln a as well. Because you would go ahead, bring that back up here, and then the e and the lns would cancel. So let's use the chain rule. d dx of a to the x equals, well, if we rewrote it as e to the x ln a, right? This is a product. Actually, no, that's a number right there. So I would just say 1a. Because we said that this is, yeah, but this, we just defined this as that. Man, math is just one of those days, man. So a to the x ln a is the derivative. That just proved to you how to take the derivative of these exponentials, because e to the x ln a is a to the x, because I would have a to the x equal to e to the ln a to the x, and these ln and e would cancel, so a to the x equals a to the x. Okay? So you cannot apply the power. Okay, let's write it formally for the road, just in case you guys think I didn't teach it. Just in case. Formally, for your notes, d dx of a to the x equals a to the x ln a. That's what it is. If I have, oh, you can't apply power law. So like, if you have this is something to remember. Like, do not pull this out. Like, this is just monstrosity right here. I don't want to see this. This is just cancer right here. That's wrong. Boom, you can't do that. It's wrong. Wrong as heck. This is right. What's there's crossed out is wrong. So if I have, I'll make this a little less graphic for you guys. If I have like 3 times 2 to the x, then I would just have 3 times 2, so f prime of x equals 3 times 2 to the x ln 2, essentially. That's all that would happen. And if I had, likewise, that f of x equals x plus 5 to the x, then I would just have, separate them. So I'd have 1 plus 5 to the x ln 5, essentially. So I'd rewrite it again and then ln the base. That's all I would do, essentially, to take the derivative. If I did f of x equals 2x times e to the x, then you do 2 to the x ln 2 e to the x plus 2 to the x e to the x. Right? I can factor out 2 to the x e to the x, so I have 2 to the x e to the x ln 2 plus 1. So then, what if I had this beast right here, mixing that quotient rule for you guys? Let's get it. Get it. F of x equals. So what happens is I just do low d high minus high d low all over low squared. So I do low d high minus high d low all over the bottom squared. So if I clean all that jazz up, hey, you didn't foil this guy, yeah. I'll leave it at that. I know you can clean it up, but that's time consuming, that's effort. Low d high minus high d low over low squared. On a test, you would have to do that. I know I'm not setting a great example, but so if you have f of x equals 2 5x squared plus 3, that'd be just like f of x equals g of h of x, right? So then g of x would just be 2 to the x, and h of x would just be equal to 2x squared plus 3. Well, 2x squared plus 3. 5x squared plus 3. Geez, slipped up there. So what happens now is I would just do 2 5x squared plus 3 1 2 times 10x. That's how you do that right there. Okay. Sweet. Okay, let's do this last example for the road. Find the equation of the tangent line when I'm not around you. Say, baby, I love you. So if I have f of x equal to x to the x, tangent line at x equals 0, then I go f prime of x equals 1 to the x plus x to the x1, 2. So I go f prime of 0, which equals 1 plus 0, which is f prime of 0 is 1. But f at 1 is equal to 1 times 2 to the 1, which is 2. So the point is 1 comma 2, meaning that y equals x plus b. But I would go 2 equals 1 plus b, so b equals 1. So the y equals x plus 1 as the equation. What? 2, 2, 2, 2. What? Monstrosity. Yeah, I got the slope right. Oh my gosh, I put in f of 0. Man, taking that fat L, that's 0. So I go 0, 0, so b equals minus 1. No. Yeah, it'd be 0, so b equals 0, so b, y equals x, that's your answer. So I accidentally put in 1 earlier, I'm supposed to put 0. Get a little too excited.